Hello everyone, Triple NI here. And since I'm building a railgun and this isn't a topic I've covered before, I thought I'd talk about my projectiles, which are these things right here. So now the thing with these railgun projectiles is they aren't as simple as the normal projectiles or bullets as they call them that are used in ordinary guns, ordinary chemical driven guns. So the projectiles of a railgun do have certain special requirements and I've tried my best to fulfill them. So the first thing obviously is they need to be conductive. There are of course many millions of not millions, there are many metals that are conductive and copper is second only to silver. Of course I can't afford silver projectiles, so I had to make do with copper. If you've been following my channel for a while, you'll be knowing that I've intended to use graphite as my projectile since it doesn't stick to the rails. This kind of graphite. So these things inside this tape were actually the original projectiles that I intended to use. And that was a few months back till I decided to change my rail design into a square bore one like this to allow more flexibility in the testing procedure. And then I had to come up with bullets that had brushes which create better contact with the rails and reduce rail erosion problems and contact arcing. And this was the first projectile that I built. So originally this was made of nothing more than just some twisted household wiring. Then I decided to add some lead tin solder 60-40 ratio just because normal bullets that they use in guns do have lead in them, and lead being a rather heavy material possesses a good amount of momentum. So this was my first, and then I discovered this, which is also called cheap desoldering wick. I realized that what I needed was right here, some good quality thin copper that wouldn't fly everywhere, that I wouldn't have to hold in place using some special glue or something. And this thing is dirt cheap. You can get so much in a roll for very cheap. I don't even know what the cost is. And then I came up with two kinds of bullets. Well, of course, all of them weren't as perfect as these. It took a lot of failed attempts right here. So a lot of failures till I perfected this design. So this is what I call my bullet version 1. So as you can see, it's copper braid and solder. I don't know if I'll show you how to make these, but still. So you have some solder. I think the structure is quite evident on the outside. So what I did was I took some solder wick and I bent it around like this twice. You can see in this projectile it's more clear. So I had some kind of a blob in the middle like this, and I added solder to the blob. And since this wick attracts solder easily, it was kind of easy to put in a lot of solder, and I ended up with these good projectiles that have copper brushes. Now the reason why these brushes are so long is because in a railgun you don't only have a force acting in the direction of the projectile, kind of an exit force. So if you have current flowing in a path like this, of course the projectile will be experiencing a force that pushes it out. At the same time, since the magnetic field is coming up out of the page and there is a current flowing in the rails themselves will experience an outward force. Now the way this thing is useful is if I have a projectile that's straight, the only force acting on it will be this outward force that accelerates the projectile out of the rails. But if I have a projectile that's U-shaped, then the outer two legs of this projectile will be forced outwards due to the Lorentz force, and they make good contact with the rails. So that's what I planned with these projectiles. And then I made a simpler version of that projectile, which is just some twisted solder wick with some solder on it on the front portion alone for some hardness. If you can see it, this thing won't focus. Yes, solder on the front portion alone for hardness. Now the reason why I came up with 2 bullets is for more flexibility. I came up with this in school as usual. Projectile types. So the first type which I showed you, these projectiles, this is the momentum type using copper braid obviously, and the mass which I got measured over here for my original projectiles thanks to my mother weighs approximately 0.55 grams plus or minus 20%. More momentum, penetration if this thing can go fast enough. The only disadvantage is it's not very aerodynamic, so it's more like a slug that you throw at a high velocity for penetration, etc. Practical use as a weapon. This thing, it's just like a lead shot actually, just a little less aerodynamic, and perhaps these copper brushes aid in stabilization if I'm really lucky. So the second type is what I call a velocity projectile. Just because these are way lighter than these, almost a little less than 5 times, 0.15 grams. For velocity, little to no penetration. Obviously, these things are going to crumple when they hit a hard target. Maybe the lead will keep them intact. And mostly used for record breaking. And what I mean by record breaking is, now that I've had all these projectiles measured and I know the energy stored in my capacitor bank, I can easily calculate the velocity for any given efficiency of my railgun, which is exactly what I've done in this huge table right here. So over here is a type of projectile and its mass, a velocity projectile and 3 penetration projectiles, and the efficiency and the corresponding energy. So 0.1% efficiency gives me 30 millijoules, and these are the velocities calculated using this formula, which is derived from this one. So twice energy by mass, the whole root gives velocity, twice the required kinetic energy. So let's say I have 0.1% efficiency, that's 30 millijoules out, and I use this kind of a projectile, so this will be my output velocity. And the same thing for different masses, and these dots represent these projectiles. Each projectile actually has a small dot or 2 or more, just to differentiate between these, since I had to get them measured individually. I had only one of these measured, so bad luck. Yes, so the green line represents the boundary between 100 meters per second and below, the orange line 200 meters per second, the red line 300 meters per second, the pink line, which is not very distinct, for the sound barrier, and the blue line for above 400 meters per second, which is absurdly powerful. I believe it has been done only once in the history of railguns by some German guy in 2005, I think, and he had a 12 kilojoule capacitor bank. But if you actually notice the efficiency values on top, if I have only 5% efficiency, using my lightest projectile I can easily exceed 100 meters per second, which is my design aim. Using the heavier ones I'll be requiring a little more efficiency, 10%, which is very high when you're talking about railguns. I haven't dared to go beyond 50% efficiency for all projectiles because that's absurd. It's absolutely absurd unless I can find a way to actually make railguns more efficient, which I have, but I won't be publishing the how to do it right now. So this is the whole table in case you want to pause and have a look at it. So yes, that's pretty much it for as far as my projectiles are concerned. Everything has already been tested. So all I require now are my rails, which I've subcontracted to a friend. Yeah, that's kind of a long story. So yes, and I also have a rather bold proposition as far as railguns are concerned, which I'll be talking about right now. And this is my bold proposition. I want to classify railguns. Of course, this might have or might not have been done before, but this is my spin on what I'm trying to do. So we've all seen railguns of many different shapes and sizes on YouTube, ranging from really small ones that are about like this big maybe, to ones that are absolutely huge, like the ones used by the US Navy that can reach Mach 7, that's 7 times the speed of sound. So isn't there a simpler way to classify railguns? It would be easier to do it by size, but then the currents and the output efficiencies may vary a lot, not even very much, a lot. So what I thought of was to classify railguns according to the current. And this is how I plan to do it. So of course it's in multiples of 5. The value has been chosen arbitrarily, no specific reason. So I'll explain my classification. So the first group will be 0 to 5 kiloamps, which I call entry level, forgive the bad handwriting. So this includes all your very small railguns powered by photo flash caps and such. They can of course be of any size, but if the current is 5 kiloamps, okay, below 5 kiloamps, then it's called entry level. I don't care what your size or efficiency is. 5 kiloamps to 50 kiloamps, which is where I'll be falling since I have around 8 to 10 kiloamps, will be low class. Cap the focus. Focus, come on. Yeah, will be called low class. 50 kiloamps to 500 kiloamps will be called medium class. 500 kiloamps to 1 megaamp will be called heavy. 1 megaamp and above, well, I haven't even come up with a name for them. They are so powerful. Now the reason I've decided to go for classification by current is I've seen small railguns that have currents of almost 10 kiloamps, so classifying it by size would be pathetic. And I've also seen quite big railguns that whose projectiles flopped out like a wet noodle if I yes, anyway, that was not the point. So this is how I plan on classifying railguns. So tell me if you agree with this or have anything to say in the comments below. And that is as far as I've come so far. Thank you for watching.